Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So, what were we doing? We were doing parameter, area, and volume. And I already told you about in the preface about the all the three things which I told you just now is uh, the terms. Three terms are perimeter, area, and uh, volume in my preface lecture. Now I'll be telling you some more figures from which we can find the two-dimensional uh, areas and uh, two-dimensional figures from which we can find the area. Now, in geometry, we deal with many figures. Uh, for example, it was square. It when it was square, all the sides are equal, and the angle is 90-degree all over the sphere. But if I just press this, I just press it towards this, I put, I exert a force upon it. What will happen? That it will be like this. Now, this is the, you can say that this is the deformed form of a sphere. Now, what is this? This is a rhombus. What is this? This is called a rhombus. It could be on this side or it could be on this side as well. Yes, on this side as well. You see that this is again a rhombus. Now, the difference between the two is that it has 90-degree all over its corners, but the rhombus don't have 90-degree. Now, this is a rhombus, but this is not a sphere. Every sphere is also rhombus, but every rhombus is not a sphere. Okay, now you see that all the sides are again equal. But how could we find? We could find the perimeter. We, we can find the perimeter because the perimeter of the sphere and the rhombus is same. The perimeter of the sphere and the rhombus are same because the sides are same sides. Okay, all over the four there are same sides. Now the perimeter will be the same. If this is, for example, 2 centimeter, then it means that all over the four are 2 centimeter. Then the total be what I told you was the perimeter. Perimeter was 4s. What was the perimeter? It was 4s. That means s plus s plus s plus s. That means 4s. Now it would have been come 4 multiplied by 2, that is equal to 8 centimeter. Now since this is a linear dimension, linear measurement, so it is the unit is in singular form. It don't have any power on it like square or cube because s is 1 over here. Okay. Now if I want to find the perimeter of the rhombus, the perimeter will again be the same because the sides are same. The if it is 2, then the perimeter will remain 8 centimeter. But where the difference lie is in the area. Finding the area, not the area, because area may well be the same in square and the rhombus. Okay, now the area of this square be s square. S square. Now it is 2 times square is equal to 4 centimeter square. 4 centimeter square. The area is 2 square is equal to 4 centimeter square. And what about the area of rhombus? Now drop, we have to drop a perpendicular from here to here to find its side. And that will be h. And the h and the area of that will be B. Area of rhombus is equal to B into H. Here B is this in your book. Okay, H is this, B is this. Let me write it in clearly. Let me write it clearly that this is B and this is B. So area is equal to B into H. Whatsoever the height is, B into H will be the area. Okay. And what about the parallelogram? Same applies when we have a parallelogram. Now this was the square. Now this is a parallelogram. Now this very parallelogram is also a rectangle, because what I said you, that this is also rhombus, and every sphere is a rhombus, but every rhombus is not a square. Now this is a rectangle and this is also a parallelogram. And what does it means? That parallelogram has its opposite sides parallel, like these. For opposite sides are parallel, the opposite sides are parallel. So this is also parallelogram, this is also parallelogram, and this is also parallelogram. But very precisely what we say to the rectangular, if I just exert a pressure upon this and just force it to move it like this, then the shape will become like this. Now the shape will become like this. Now this is called a parallelogram. Okay, now this is a parallelogram. So in a rectangle, you know that the area was, now this was the length and this was the breadth. So the area was length into breadth, A is equal to. But in this case, again, the height has been involved. So it will become B into H again. Okay, now this was about the uh, quadrilaterals. It was about the quadrilateral. And what about the triangles? Now we have three types of triangles with respect to their angles. We have three types of triangles with respect to their angles. First is the equilateral triangle. This is a right angled triangle. If you see this sign over here, then it is a right angled triangle. And third one is the obtuse triangle. Now there, with respect to their angles, now these two are with respect to their angle and this is with respect to its side. Now with respect to its side, it can also be an isosceles triangle. Okay, it can also be an isosceles triangle. So this is an equilateral triangle. All the three angles are equal. So this angle, this angle, this angle are equal. Now what we do here, we have to find, now if I want to find the perimeter for all these, we will just simply add, measure this, measure this, measure this. Okay, now this will be the parameter. Now suppose if it measures 4 centimeter, then for example, if it is an equilateral triangle, all the three sides will be 4 centimeter. So the perimeter will be 4 3 times is equal to 12 centimeter. But if I want to find the area of this triangle, the area of triangle, then I have to drop, what I have to drop is a perpendicular from this vertex to the base of the triangle, and this will be the perpendicular. So what will be called, this will be called H. So it will be called, as I told you, half base into height. Half base into height. Okay. Now similarly, all the three triangles will have half base into height. This will also have half base into height. And this, from where we will get the perpendicular. We'll extend this side, we'll extend this side and we'll again drop a perpendicular from here. Again drop a perpendicular from here. So it will become H. So the formula will remain the same, half base into height. Or you can also say that B, half base into height, BH upon 2. BH upon 2. So, and about trapezium. Now about the trapezium. Then we'll start the exercise. Now about the trapezium. You know what is a trapezium? Now in the trapezium, we'll find two sides parallel and two converging. Two sides are parallel and two sides are converging. So if this is the figure, say this is the figure, you see that two sides are parallel and two are converging. Now this is a trapezium. Okay. Now if you want to find uh, the parameter, then it is easy. We'll add this side, this side, this side, and this side. But if you want to find the area, then you again have to uh, drop a perpendicular from here till here. It will be h. Now this is the, you have drawn a perpendicular from here to here. Then you have to find the, you have found h. Now this side is called the base. Now this side is called the base of the trapezium, and this is the other side of the trapezium. Okay, this is the top side and this is the base of the trapezium. Now what will be the formula for this, for the area? Because perimeter is easy and area is a little tricky now. So it will become half base into height, half a plus b, a plus b, a plus b into h. Okay, my dear students, just remember the formula which I am telling to you, because it will be repeated in our exercise. There is another type of trapezium. Now this is another type of trapezium. You see that two lines are parallel, but two are converging. But luckily we have one side which is at 90 degree. Okay, so the formula will remain the same. Now about some other two types of uh, two-dimensional figures other than trapezium, other than quadrilateral, other than triangles. The other two dimensional shapes are two-dimensional shapes, not two-sided shapes. Okay, two-dimensional shapes. Two-dimensional shapes may be the kite. You have seen the kite. Now this is the kite. Now, and the hexagon I told you in my last lecture. Now these have some different type of formulae, and irregular pentagon, and there may be also an irregular pentagon, maybe like this. I make it like little. Now this is an irregular pentagon, this is hexagon, this is a kite. Now these three figures, one, two, three figures. Now these three figures, we can find the area of these figures also, but there are different methods of finding the areas. For example, if we are dealing with this kite, so you see that I'll draw a line in between the two. Now you see that there are two triangles, one triangle and two triangles. There are two triangles. So number one triangle is this one and number two triangle. Now I have to find the area of two triangles instead of one triangle. So the total area will be the area of triangle 1 and the area of triangle 2. Now this is the whole story over here. Area of triangle number 1 plus area of triangle number 2. What is the area of, now this is H1 and this is our base. So it will become half base into H1 plus half. Now base will remain the same. Base will remain the same, but height will become 2 over here. Well, my dear students, I was discussing about some irregular figures or the odd figures. Unlucky, the camera was put off due to some reasons. So I could not complete that. So I was discussing about the kite. Now this has been the kite. Now you see that I have divided this into two triangles. Let me make it dotted. I have divided this kite into two triangles and one triangle is this one the first triangle and this one the second triangle. So we can easily find, as I have told you, that how to find. Now just to recap, now this is the height h1 and this is the height h2. Okay, base is the same for the area of first triangle. The area of first triangle was half base into height 1 and the area of second triangle was half base because base is same for both triangles h2. And my dear students, when we'll add them up and what will be our answer will be the area whole kite. So our next example is for a regular hexagon. We can find something from here also. Now this is a regular hexagon, maybe it is. So you can make something like this, like this. Now you see that there are two triangles. Now this is the first triangle. This is the first triangle. First triangle. This is the second triangle. And maybe these are same triangles because this is a regular hexagon. And what is this? This is a rectangle. So you can easily, if it is base, it is base, it is side, it is side. So you can also easily find. So you can always find some triangles and regular uh, figures in the irregular or other two-dimensional figures to find out the area. It is not a difficult task. So now let me proceed straight to the exercise. I am leaving the work examples because I have already discussed many in the preface. So I'm going straight to exercise 7.1 now. Now in exercise 7.1, by measuring the length of each side and adding them together, find the perimeter of each of the following. Now there are some figures given like triangle, a quadrilateral, an irregular quadrilateral, and you have to find the perimeter of that regular or irregular polygons. Now question number 1, I have to find the perimeters. Now it is very easy. Now for example, this figure is given. Now for example, this figure is given like this is almost like this. So I am going to reproduce that figure. Now, my dear students, this figure has been given in question number 1, part 1, question number 1, part A of exercise, and exercise is 7.1. Now, in your book, what is in your book? This sort of figure is given, and we know where is which one is your book. You have already, I have shown you this book many times. This is your book, and the exercise we are doing is this one. Okay. Now, this is your first question. Now, since I have reproduced it, I have reproduced this triangle. So, I have to find its perimeter. Now, for the perimeter, what I have to do is, this is the figure in your book. I have to measure it like this. Now, this is 35 centimeter. 35 centimeter. Okay. And this is 30 centimeter. And how much it is? It is 17.5 centimeter. Now, my dear students, it is not the measure which is in the book. In the book, it may be, it is like 5.5 centimeter. Now, in the book, it is 5.5 centimeter. Here it is 4 centimeter. And 3 centimeters is over here. To explain it, I have made this figure a bit larger, that you must understand what is the question. So, if I take the measures of the book, it will be 7, 7 and 5 is equal to 12, 12.5. The perimeter in the book will be 12.5 centimeter. P is equal to P is equal to 12.5 centimeter according to book. According to book. Now these are the measures: 4 centimeters, 5.5 centimeter, 3 centimeter. Now this is the measure from which we have to take, which we have taken. This is again the measure, and this is again the measure over here. And if I take my own, the figure on the board, it will be 35 plus 30 plus 17.5. So it will be 0.5, 2 and 6, 8, 82.5 centimeter. Now this is what I have drawn on the board, the perimeter which I have drawn on the board, and this is the figure in your book. This is the figure in your book. Approximately, this may vary, uh, and don't be afraid that it will vary. Yes, it is exactly the same in your book. Exactly the same in book. The answer is the same. This is the right. Okay. To let you understand, I have taken these measures. So, my dear students, let me proceed to another example, and that is example number B, because it is a little tricky. Now, in the part B, an irregular polygon is given. Now, let me do it in freehand. Now, this is what I have reproduced, almost what I have reproduced. Now, this is an irregular quadrilateral. So, for example, now we have to measure all. Now, for example, this is A, B, C, and D. The names are not given in your book, but I have named them to let you understand. So AB in your book, now in your book, specifically in your book, AB is 1.5 centimeter. Now this is 1.5 centimeter. BC is 3 centimeter. This is in your book. 4 centimeter. I am measuring with this ruler, and again we have 3 centimeters over here. Okay, now we have to find the perimeter, so need not any uh, constructions. Now this will 3 and 3 6, 10, 11, 11.5. So the P is equal to 11.5. We'll add up all the measures. We'll add up all the measures. 3 plus 3 is 6, 6 plus 5, 4 is 10, 10 plus 1.5 is 11.5. So you will do all these like this. Now calculate the perimeter of each of the following shapes. Now the measures are given in your book. The measures are given in your book. First one is very simple, and question number 2. Question number 2. In question number 2, a regular rectangle is given. A rectangle is given regular. Now this side measures 5.5 centimeters and this side measures 2.5 centimeters. Since this is a regular, because these uh, signs are given on each of the corner, so it means that this is a regular rectangle. So we'll just, what was the perimeter I told you? It was 2, perimeter was 2 in my first lecture, L plus B. So this is L, this is B. It will become 2, 5.5 plus 2.5. That will be equal to 2, 538, and that will be equal to 16 centimeters. Okay, is equal to 16 centimeters. Now let me take part E out of it. Now part E is, now let me take part E. I'll be drawing freehand, so don't worry about my drawing. It is almost good. Now this is 7.3, 7.2, 7.2 centimeter. This is 8.4 centimeter. Now all the corners are at right angle. All the corners are at right angle. So this is a very good sign. 2.8, 1.9. Now this is 1.9 from here to here, and this is again 2.8, 2.5. This is 2.5. This is a less. Now this, you see that this is 2.8 centimeter. This is 2.5. This is broader than this. The depth is 1.9 centimeter, and you see that this dimension is not given, or this measure is not given from here to here. Now if I want to find this A and B, what will I do? Very simple. It is very simple, that how we'll find A and B, because this measure is not given, but you see that this measure is given. Now we'll add this 2.8, 2.5, add this 2.8 and 2.5. It will become 3 and 5.3 centimeter. It will become 5.3 centimeter. Now you see that these are all parallel and at right angle. So we'll take this 7.2 centimeter and we'll minus 5.3 from this. We'll subtract 5.3 from this. So from 12, it will become 9 and 6, 1.9. Now this 1 point A to B is 1.9 centimeter. 1.9. 12 minus 3 is 9 and 6 minus 1 is 6 minus 5 is 1, 1.9. So all the measures, now all the measures we have found, these are given, this is given, this is given, this is given, but you have found this 1.9 also. So you will add up all these figures. Now this is again 8.4 centimeter because it is a regular figure given. So it will become, add all the measures. Now we are going to add all the measures. So this is 7.2, this is 7.2, 7.2, 7.2, 1.9, this is depth, and 1.9 again because this is 1.9, also 1.9. 7.2, 7.2, 1.9, 1.9, 8.4, 8.4. Now how many meters? You can see that 1, 2, 3, 4, 5, 6, 7, 8. 1 and 1, 2, 3, 4, 5, 6, 7, 8. I already added these three in this. So 18, 20, 22 and 8, 30, 10, 27, 10, 17, 18, 19, 27 and 27 and 8, 35 centimeters. This was part E. Okay. Now the total perimeter is 35 centimeters. I hope you would have understood this. Now you can do all these questions right. So I think it's enough for today, and we'll be doing from question number 2 to the end of the this exercise in our next session. So it's time to say you goodbye, and it's time also to sign off. And please subscribe and also join my Mathematic channel, Mathematic group on Facebook. So it's time to say you goodbye. Allah Hafiz.